Presentation. It'll be presented by Orlando Barrera behind me and Josh Sokol. They'll be talking about how to get the data out once you've found it. Gentlemen, welcome. Thank you.
How's everybody doing? Yeah, doing good? We're tired, sleepy, a little bit? All right, cool. So a new technique in data exfiltration and confidentiality. I realize that's a long title. When we did this talk out at B-Sides Las Vegas, we called it How to Hide Your Porn. A little bit shorter title, not quite as descriptive or perhaps more descriptive, so that's why all this stuff is right here. But really what we're talking about is data exfiltration, right? How do you get your stuff off of the system that you've compromised or that's been compromised and get it into your hands without people knowing about it?
All right, so who am I? Orlando Barrera. I have a couple of security exploits, some vulnerabilities. I'm basically a code monkey. I work as a security analyst at NSS Labs right now, and that's about it.
And me, I'm Josh Sokol. I presented at HouSecCon last year. I was the lunchtime keynote. I'm the Austin OWASP chapter president, at least until January when I hand it over to somebody else. I'm the co-chair of what is now the largest security conference in Texas. It's in Austin. It's called LastCon. Check it out if you haven't been. I'm here because I like to talk about security. I'm not one of those limelight people or whatever. I just like to talk about things that I think are cool, and I like to learn about things that I think are cool. So that's why I'm here. I'm not selling anything. I'm not talking about my company. I'm not doing anything like that. In fact, if you ask me which company I'm from, I'm going to very hesitantly tell you I don't want to talk about that. So if you want to write about the talk or whatever, do so. Keep my company out of it. This project started, we do these weird monthly Austin Security Professionals happy hours. There's lots of cool people that hang out in them, and we talk about lots of strange things. And for some reason, we started talking about how to hide your porn. And I got this idea that how to hide your porn would be a great title for a presentation, and then I had to come up with something to go along with it. I started talking to Orlando at the Austin B-Sides event, which is a really, really fun event. It's free. It's in Austin right around South by Southwest time, and by the next morning, Orlando had actually written what is now the base of StayGo, which is our tool. This was a quote when we originally did this. It was at B-Sides Las Vegas, thrown by Chris Nickerson, or organized by Chris Nickerson, and I thought it was very fitting, right? The internet is really awesome because it gets you your porn, and by porn, we basically mean stuff that is important to you. You want to talk about that?
Yeah, that's fine. So what we're considering porn is data worth hiding, or data that's worth protecting, anything you want to hold on to, you don't want other people to have access to. Next slide, I guess. So he's going to talk about how not to hide your porn.
All right. So what don't you want to do to hide your porn? These are things that are semi-effective, maybe completely effective, but a little lame, whatever, right? So the first thing, hidden files and directories. Hidden files and directories was cool back in the 80s when you were trying to hide things from your parents, right? Really all it is, you know, go into properties, check the little hidden box, and then it doesn't show up as a directory or as a file in that folder, right? It's really good if you're trying to hide things from somebody who's not very technical at all, but when it comes down to hiding from, say, a forensic investigator or something like that, it's useless, right? So the second thing is renaming the file or extension. Again, if you're just trying to hide data from somebody who's kind of lame, doesn't understand technical things, whatever, renaming the file or extension is fine, right? I change it, you know, from porn.jpg to porn.pdf, and nobody knows the wiser, right? Especially if they're doing a search for images, right? But again, kind of lame. The other thing that you can do is the ET thing, right? Put with other similar files, somebody goes, they open the closet door, and they have no idea what's there because it looks like everything else. So if you have a bunch of images, throw it in a folder with a whole bunch of other images, that kind of thing. You can also bury it several directories down. So in this case, you know, you have something, you found my porn stash, right? But it's buried down in do not open this folder. That's not cool. Why are you invading my privacy like this, etc., right? So yeah, guilt is infinitely more effective than encryption or obscure file names, but really in the end, this doesn't work that well, right? Because somebody can just click, 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 and finally they get to your stuff. You can place it with other files in compressed format. The idea being that if I zip it up, if I put everything together in one archive file, and you're doing a search on the file system, you're not going to see the stuff in the archive file. You're going to see the archive file, and that's going to bypass whatever filters you're looking for. So if you're looking for images, it's not going to show up as an image. It's going to show up as a zip, right? Again, this doesn't work very well these days because a lot of the search engines, a lot of the Finder features of the operating systems can actually look in these archive files. Alternate data streams is actually really cool. It is a feature of Windows, and what we can see here is there's a file called setup.act.log, right? And what we do is we create an alternate data stream for this file. Well, what that alternate data stream is a appendage to that file that has some other data. But when Windows displays this file in a normal setting, it only shows you this. It only shows you that original one. You have two sets of data. The file name is exactly the same. When it comes down to searching the file system, you don't see both things unless if you know the right flag. So if you use this right flag, now all of a sudden the alternate data stream starts showing up, and hiding it is kind of useless at that point. So cool feature. I don't know what this was intended for other than hiding stuff. But it works as long as you don't know the flag. Again, for a non-technical person, this would probably evade them. This was a cool tool that I found when I was doing research on this project called Spam Mimic. This is a website you can go to, you enter some text. In this case, my text was the password is prawn. And what happens is it takes that text and it actually encodes it into a spam message. And this spam message, you can dig through here all you want. You actually won't find any of these words in there. They do a very good job of jumbling it up. But then you can take the spam message, send it to your buddy. He opens it up, he goes to the decoder for this website, and all of a sudden he gets back the original message. So if you're trying to evade things like a sysadmin or somebody who's monitoring your network, this is actually a pretty good way to do it. He just sees it as spam. Your buddy, however, can actually take this message, decrypt it, and get the original content that's there. The problem, again, is if a system administrator knows to look for this, they can go right to Spam Mimic and decode it there as well. Hidden partitions. This is another thing that you can do to hide stuff. Very, very simply, it's another partition on your hard drive, but it's something that doesn't show up within the file system. So you can actually store data in there, and somebody who's just doing a normal search of the hard drive won't find that. The problem here being, if they actually go and look at partitions and how the disk is set up, then they can find your hidden partitions. Very similarly, invisible partitions work pretty much the same way. You can create a partition that's invisible to the operating system, and basically you can store your data there. And again, if I actually go and look at the partitions that are on the system, then that data becomes readable. This is actually a really cool thing, slack space. When you allocate files on a hard disk, your files take up multiple sectors. So in this case, here's our data, and our data takes up all of these sectors. The problem is our file is just shy of making it to this last completing out this last sector. So what we call this area between the end of the file and the end of that sector, that's called slack space. And what we can do is we can hide data in that slack space. And all this slack space kind of adds up on your hard drive to make a pretty decent place to hide data. Again, if you're a forensic investigator, you can look for these things. You can look for the end of the file and then look to see if there's data inside that slack space. So it's a good way to hide it from somebody who's not technical, but I wouldn't use this to hide my data from law enforcement, for example. Also similarly, you can hide data in bad blocks. And by bad blocks, you can actually label a block on your hard disk as being bad. That tells the hard disk, don't use this space on the hard drive. And by labeling it as bad, now you can store your stuff in there and access it as soon as you flip the bit back and can use it again. So very cool, you can put stuff in there as well. Anybody else have any other ideas? I know this isn't a complete list. This was just some stuff that I was looking through and found, and I thought this was a pretty decent list of things that are out there. So let's talk about some stuff that works. Encryption, right? This is the classic security practitioner example of something that works to hide your data. The problem here is this. the presence of encryption provides reasonable suspicion. This was a guy, he was at the Misty InfoSec World Conference when I was presenting out there in April, and he's a forensic investigator. He's a guy who does this for a living. And so as a security practitioner, as somebody who has something to hide, maybe it's bank account information, whatever, if you have encrypting software on your system, if you have encrypted archives on your system, if a law enforcement official were to see that, they may be compelled to try and get that, right? So if you're trying to hide data, having something that encrypts the data or having encrypted data on the drive is probably a bad thing. And taking that a step further, this is actually showing the FBI, William Sessions, has said that they consider the use of encryption to be a threat to the federal government. So they don't want you to use encryption because they know that by using encryption, you're preventing them from doing their job. However, they want to be able to use encryption. Did you want to talk about this one? Okay. So this is just another example here. This is a particular case where this woman was brought up on charges, I believe it had to do with a mortgage scam. And what happened was this woman was actually using encrypting software on her system. Well, the judge in this particular case said, you have to enter your password and basically self-incriminate because that's how we're going to build the case against you, right? So the judge is actively trying to compel this woman to enter her password, to decrypt that archive, and she's like, no, that's my private data. Well, it turns out that where the US government is concerned, they feel like your private data isn't private. So this guy's thinking about something, right? If having encryption software on my hard disk or encrypting archives on my hard disk compels them or makes them want to compel me to give them passwords and things like that, we need to avoid that, right? So in comes, oh yeah, this is a XKCD, I believe, cartoon. And this is really what ends up happening, right? In the crypto nerd's imagination, he's got this laptop, it's all decked out. He's got like this super awesome encryption scheme, right? He's 4096-bit RSA, whatever, right? And the guy tries to take his information and he can't crack it, right? That's the crypto nerd guy. But in reality, this is the government, right? They take a $5 wrench, they beat you over the head until you give up the goods, right? We want to prevent this. So, anybody know what's hiding in this picture? All right, that's what's hiding in this picture. In comes steganography, right? The ability to hide data within an image itself. So, this is that same investigator that I talked about before, and this was that same presentation I went to at InfoSec World. He said, the cases I've lost, I've been able to detect steganography, but not break it. And I thought, dude, that is a great quote for this presentation, because that's what we're talking about here, right? If I want to hide data from somebody, I should do this. I should encrypt it, I should StayGo it. Well, these guys figured it out before I did, right? Terror groups have been using this for a long time, since 1993. They're basically using encryption and steganography to hide their data, to do secure communications amongst each other, right? So this isn't anything new. Did you want to talk about this?
All right, so when we started looking at it after we actually did our project, we found some other applications that kind of take this concept. The difference is all these applications, you need to have software on your system or install an operating system. And again, that gets back to that reasonable suspicion. If you have encryption or steganography software on your system, that provides them reasonable suspicion. And this is a list of some other projects that kind of go along encryption, steganography. Next slide. No. Yeah, definitely. It's not a complete list. So our tool, it's a new concept for data protection and exfiltration. And we came up with something we call StayGo. So it's at www.staygo.com. It's basically a web application that provides this encryption, steganography benefit while actually providing, I guess, an extra layer of abstraction of that data. What's different about this tool is, of course, it's web-based, HTTPS upload, and the entire data is broken up to binary data chunks. And each data chunk is then encrypted and then StayGo'd in images, and those images are placed out in the cloud. So there's no data on our server or any data on your client in system, on your system. And the benefits of this technology, of course, is data exfiltration to remote system via standard port, 443 or port 80. Encrypted contents prevent others from accessing data, and the StayGo contents prevent others from finding the data. So basically, you have a bunch of images out there in the cloud that have your encrypted data in little chunks, and good luck trying to find all those images, decrypting it, de-StayGoing it, and putting it back together. And like I said, nothing stored locally, so this provides plausible deniability. And let's go into the architecture of the proof concept tool. So our main goal was to provide confidentiality, integrity, and availability of your data, right? The CIA triangle thing. So what we do is we take a binary file, whatever file you want to upload, we take the contents of that file and we break it up to data chunks. So you could have an encrypted file, you could have something that's already compressed, you could have images, video, executable, binary, DLL, any type of file. Take it, insert it, it'll break it up to data chunks, and then after it breaks it up, it creates a hash of not only the entire data file, but each data chunk to provide, I guess, integrity of that data. So you can make sure that nobody's messed with that data on the other end. When you get it back, you could compare those hashes. And this is just a simple example of an algorithm that using, if you use encryption, it actually adds some padding to the data. So if you're using encryption, we take the chunk size and limit it to smaller bits of data chunks. And this is just showing the checking of the hashes. So you have a hash before, your hash after. If there's any changes to that binary data, the hashes won't match. We know something's gone wrong, and we won't continue the process after that. So this is just a simple example of the algorithm for checking the hashes. So you have your hash before, of course, your hash after. If they're not equal, we can't validate the security or integrity of that data, so we don't process it any further. Next. So encryption. Every data chunk is encrypted prior to Steganography using a simple encrypt or decrypt PHP function, but you have the option to use AES 128 or 256 encryption, and that's to provide data confidentiality. So every piece of data is encrypted, whether you want AES or just simple encryption, decryption functions. This is an example of some of the code for the actual encryption of it. As you can see, it's just a function, takes it in there, decrypts your data, or encrypts it, I'm sorry, on this part. Again, this is the reverse of that algorithm, just decrypting the data. And what's different, okay, so different Steganography. We've talked a little about the encryption. Of course, it's kind of basic encryption. The Steganography is what really makes this tool a little bit different. There's a lot of different techniques for Steganography. One is to store the data in the common field of an image. That's really lame. It's not really Steganography. Anyone can find that. You could use the unused space, the color space. So usually you have like a 32-bit color. And a lot of times they only use 24 bits, so you could use that extra space. And of course, you could use the transparency channel, which is the alpha channel, which gives you about 7 bits of data per pixel. Next slide. And this is a really cool technique. We use something along these lines with a little different algorithm. It's called pixel value differencing. So what it is basically for every pixel, you have an algorithm that compares the pixel prior to and after. And it takes an algorithm that says, is this pixel value, odd or even? And with that algorithm, you can have symbolic binary data stored within your StayGo image. Do you understand? So it's not actually binary data stored within the image. It's symbolically represented by the difference of the pixel values. Right? So we took that kind of concept and used it within StayGo. Each primary color is altered to be either even or odd. So that allows us to store 1 bit of data for each every primary color. You get about 3 bits. So for your red, green, blue value, you have, if it's 255, it could be 1. If it's 254, 0, that kind of symbolic representation. So there's not actually any binary data stored within the images. It's symbolically represented by the value of the pixels. So the advantage of this method is that, like I said, there's nothing actually stored in there. It's just symbolically represented by the pixel values. And we were able to get about 175 kilobytes of data with compression in an 800 by 600 pixel image, which isn't bad. This is an example of the actual algorithm for StayGoing the image. So as you can see down at the bottom, it has a simple function to put the data file, the image, the key, and then the image file that's actually storing it to. De-StayGoing, it's the same thing. It's just a simple function to get the image back from the encrypted response URL. You provide the key and it grabs your data back. So now we're going to do a little demo of the tool so you all see all this in action.
All right. So I learned from my buddy Robert Hansen that live demos are not a good idea. Wireless networks are flaky, yada, yada, yada. So what I have is a pre-prepared video for you guys, and I realize like aspect ratios and whatnot are a little funky here, but hopefully you can kind of see the basics, right? So let me click play. We log in with our username test and our password. Click login. This is the actual StayGo tool. You can see kind of the interface, very simple, StayGo page, de-StayGo page. On the StayGo page, we give it a name for the project. We have the option of providing a movie name. This is used to pull the images that we then put the data into. We give it a key, and we can determine what kind of encryption we want. Here we choose AES 128, and we choose a verbose output. We select our file. We go ahead and click submit. It goes ahead and updates. First thing it does is it pulls down the image set. It'll actually pull 40 images at a time just so that we have something to go off of. We don't always use all 40 of those images, but it's nice to kind of pre-prep it so that the rest of the work goes faster. You can see here it's actually chunking out that image, or the text file that I uploaded. It goes and embeds it, does the encryption, embeds it, and there's our image right there. Now that image shows up because we selected the verbose output. If you don't select verbose output, it won't do that, and I'll talk a little bit about why later. I went ahead and I selected that URL. We go ahead and click there, and sure enough, it shows up in Imageshack. It's just a file sitting out there on their servers out in the cloud. Now when we want to get that back, we go to our de-StayGo page. We go ahead and select our project. There's our passwords project. We have to enter our key so that we can decrypt and de-StayGo. Again, I selected verbose output, and you can see the project right there. We click submit. It goes out. It grabs that file from there. It reassembles it, decrypts it, and we can see my original password document. Those are all my real passwords, by the way, so don't pay attention. Do you have a question? Sorry, sir. Yeah, so the user is able to provide their own key for this, and we'll talk a little bit about this later. This is a proof of concept tool, so feel free to play with it, whatnot, but don't trust us, whatever. We're kind of nefarious in that way. But yeah, you basically provide your own key. That key is actually used to do the steganography, to do the encryption. So unless if you know the key, there's no way to get that data back. The answer is, so the question was, do we enforce any sort of length or password requirements or anything like that? We are bad security professionals. We don't do anything like that. It's up to you to figure that stuff out. It's a proof of concept tool, so we don't do things like that. We don't limit you in that way.
So on this comment, I just wanted to mention, obviously you're concerned about the security on the site and all that, and I don't want people to rely on the security. That's why you could upload any kind of file. So if you want to add your own encryption to it, compress the file, do your own steganography, and then use this tool as a data transfer medium. That's mainly what this is intended for, is a way of transferring data. By all means, you could do that, and the tool should accept whatever data file you want. So you could do your own encryption security on the back end of the file and wouldn't have to rely on our security measures here. Okay.
Yeah, there will be some time at the end. We'll leave time for questions. Questions are a sign of intelligence. So, all right, let's go here. So this is another demo, and this is just going to show uploading a different type of file. The first one was a text file. This one is actually an image file. So same kind of deal. We enter the name of our project. We select a movie. This time I selected Goonies. We give it a key. We go ahead and select verbose output. I never selected encryption on this one just because encryption tends to add extra stuff to this, makes it take longer. So for this particular example, I decided not to because the image was a little bit bigger. We go ahead and submit. And I did a little bit of time-lapse photography here, so it'll go a lot faster. Another benefit to not doing the live demonstration. And what you can see here is it's actually taking the image, it's splitting it up into chunks, and each chunk it's embedding into a new piece. And so it grabs 40 images at a time, starts embedding each chunk into one of those images, and then uploads every single one of those images into Imageshack. So when we're all done, we're going to have lots and lots of images that are up there. They can all be reassembled then for our original data, which in this case is an image. So I drag it all the way down here, and you can see all the images that got uploaded. Lots and lots of Goonies pictures. And at the end, it'll give us kind of a little summary. In this case, there were 28 images that were uploaded successfully. Some of the images didn't have enough to store the data, so they were thrown out. So we go to the StayGo page, we enter our password. Again, we select our project. There we go. All right. And we're back. Okay. So you can see it grabbed every single one of those 28 images back out of the image share. All those images, we can see it took about 30 seconds to de-StayGo this guy. We can see the original file size that was there. We can see that we matched with our de-StayGo file size. It also does the hashing behind the scenes. And let's go ahead and get the project file. Asks us if we want to open it. We go ahead and say OK. And up pops the image that I had uploaded. Cool. So there you have it. This is the StayGo tool in action and what it does. So, full disclosure and caveats. Maybe. All right. So we've tested a bunch of file types to make sure that they work. Well, a few right here. We've tested way more than this. Text files, zip files, MIDIs, images, all sorts of types of images. But as Orlando said, we've actually, the way that this algorithm works, it's just working on binary data. So in theory, it doesn't matter what file type you're using. Anything that you upload, whether it's images, videos, whatever, it should work. AES 256 encryption. So this is experimental. The reason why
retrieve any usable data if you're able to do it. Yeah. But like we said, to circumvent that, all you need to do is add a random watermark to every image that you scrape from online, and there's no original image.
So what we found with this is that high definition images, because of the fact that they're high def, are the best images to use. They can store more data in it because they're bigger. So unencrypted data. So the upload's encrypted, right? It goes via HTTPS. There shouldn't be any issues there. But the file exists on the server for a very short period of time before it gets chunked out, encrypted, StayGo'd, whatnot, where it is in an unencrypted state. So it's possible that that unencrypted file might reside in memory, might reside on disk at some point. So there's some temporary location. There are ways that you could probably clear that out. We just haven't gone that far. SSL, Robert Hansen and I gave a talk at Black Hat a couple years ago talking about issues with SSL and whatnot, but it's very well known. We use a snake oil cert because I didn't want to buy one, frankly. So snake oil certs lead to man in the middle, so if you're trying to use this tool for anything that you care about, just heads up. CAPTCHA, the CAPTCHA works really well in Firefox. It works in IE, but you have to click the right, yes, I accept this, do this, whatever, from the dialog boxes. So easier if you use Firefox. File upload size, we've actually restricted the file upload size for the demo. It's 102,400 bytes for the demo. That was arbitrary. We just chose a random value. We could change that or whatever. Yeah. If somebody uploaded very large files, it could certainly bring down our tool.
You could upload like a movie into a bunch of images, and it could take a long time. So yeah.
All right. Cache. So caching is very, very popular on the internet these days to speed up website performance. There's all sorts of things like squid proxies and things like that. Bigger files. So we use image files. And image files are great, especially if you're talking about text, for example. Thank you very much. Check. All right, so bigger files are great if you're talking about things like text. But if I want to do things like images, you saw there that it took 28 images for me to encode one image file. So what if we start doing things like using MP3s or using MPEGs, movies, things like that? You could potentially use things like YouTube as a repository or SoundCloud as a repository, and you can store far more data in those files than an individual image. We talked a little bit about this, the caching issues. We never implemented this. This would be like one line of code, so we just kind of thought it was silly. But you could add no cache or HTTP expires headers, and hopefully that would tell the cache, the proxies to just not cache that stuff, right? Not all proxies would listen to that, obviously, but it might work. All right, so back to the future. We're not the only guys who have thought about something like this. When we were doing research on this, we came across this guy. This is Web-Based Covert File System. These guys, May 2007, they outlined how to use Steganography to create an actual file system. And this thing actually was it had inodes and data and all sorts of stuff. It was fantastic. And this was actually based on images within Flickr photos. And so they created an entire file system based off of steganography. Very, very cool. Took it a step further. They called it PixSF. You can actually go and download PixSF. The privacy-enhancing image-based collaborative file system. Really cool. They took it a step further. They have automatic image selection from a video. They use Tor to additionally protect users, so it was random routing across the internet. They took that covert FS that we talked about, and they put it on top of this Fuse framework, and ultimately they have an entire file system that's based off of steganography that's randomized across the internet.
Then you have the software on your system.
Yeah. So the issue with both of these is you still have the software on your system, right? You still have that the thing that's going to give them that reasonable suspicion, and they're still going to come after you. So, in closing, it's a proof of concept, right? This is not a production application. And we said this a couple times. This was just something we kind of wrote up. We thought it would be a cool idea, a cool proof of concept. You are free to play with it, though. It's for educational purposes only. It's a bit redundant, but we're not responsible for your use or misuse of this tool, right? You can do some naughty things with this. Please don't. But you could. And that's the reason why Orlando and I have not released code for this tool. All comments and opinions are the property of us. They don't represent our employers or their policies. Like I said, my employer's name is completely out of this. For that reason. And all content is provided as is, no warranties, assurances, guarantees, whatever, right? Traditional disclaimer. So, with that, questions? You were first.